Imagine a time before time existed. A realm where space had no meaning, where the laws of physics as we know them break down completely. This is where the story of our universe supposedly begins. Initially, there was an infinitely dense mass of matter, a singularity compressed beyond comprehension. Then, in a moment of unimaginable energy, it exploded. That explosion, now known as the Big Bang, gave birth to everything we know. Atoms, molecules, stars, galaxies, light, time, existence itself. For generations, physicists have held tightly to this theory. It was elegant, powerful, and consistent with nearly every observation. According to the Big Bang model, the universe started about 13.8 billion years ago. At that moment, all the matter in the universe was compressed into a tiny, burning hot point, smaller than a single atom. Within minutes of the explosion, the basic elements of matter formed. The universe, once hotter than anything imaginable, began to cool and expand. Galaxies formed. Stars were born. Planets appeared. Eventually, life would emerge on at least one of those planets. And the evidence seemed to confirm it. The cosmic microwave background radiation, leftover light from the Big Bang, was detected. The distribution of light elements like hydrogen and helium matched the theory's predictions. To this day, astronomers continue to uncover findings that support this model. Our best instruments and observations paint a picture that aligns remarkably well with this explosive origin story. But as science digs deeper, cracks begin to appear in the foundation of this theory. Because as accurate as the Big Bang model may seem, it fails to answer one of the most profound questions of all. What happened at the very beginning? The moment of the singularity, the so-called start, remains a mystery. Our current physical theories cannot explain it. General relativity and quantum mechanics, both powerful tools in their own right, collapse under the weight of infinite density. The math stops making sense. The singularity is a wall we cannot yet pass. And so, a new wave of theories has emerged, ones that seek to go beyond the Big Bang. Among them is string theory, which suggests that the universe's smallest building blocks are not particles, but tiny vibrating strings. This theory tries to unify all forces in nature, including gravity, into a single framework. In doing so, it opens the door to a radical possibility: that the Big Bang was not the beginning at all, but part of something much larger. This brings us to the idea of the ekpyrotic universe, a concept rooted in ancient Greek philosophy. The word ekpyrotic means conflagration, a great cosmic fire. This theory suggests the Big Bang was triggered by a previous cosmic event. The universe, it proposes, is part of a grand cycle. Expansion, contraction, rebirth, over and over again, forever. Instead of a beginning and an end, there is rhythm, a pulse, a heartbeat of the cosmos. And it gets even more fascinating. Nobel Prize-winning physicist Roger Penrose has proposed a theory known as cyclic cosmology. He discovered a stunning mathematical connection between the cold, empty state of the universe in the far future and the hot, dense state of the early Big Bang. Through a process called conformal transformation, Penrose demonstrated that the universe's end and its beginning can be linked by adjusting size while preserving shape. In other words, from a certain mathematical perspective, the end of one universe is identical to the start of the next. But how is that possible? According to Penrose, at the end of our universe, all matter will be consumed. Black holes will evaporate. The universe will be cold, dark, and lifeless, filled only with scattered radiation. But in this state, time and scale become meaningless. With no matter to measure change, time stretches into eternity. From this vast emptiness, a new universe can be born not from nothing, but from a kind of physical emptiness that still holds structure. A new Big Bang, a new beginning. This leads to the idea of an eternal universe, one that is constantly dying and being reborn. Each cycle gives rise to another. Each universe leaves behind traces in the next. Penrose suggests that tiny anomalies in the cosmic microwave background, faint scars from a previous universe, could be the evidence we need. With the help of the James Webb Space Telescope, scientists are now searching for these clues. And astonishingly, some discoveries are already challenging the classic Big Bang model. Galaxies too old and too massive to fit within the timeline of a 13.8 billion-year-old universe are being found. If these galaxies existed too soon after the Big Bang, perhaps the event we call the Big Bang wasn't the true beginning. Maybe it was simply a transition, a phase in an eternal cycle that stretches beyond imagination. Even famed physicist Brian Cox has voiced doubts about the Big Bang's role as the ultimate origin. He questions the idea that something can arise from absolutely nothing. It defies not only logic, but the laws of physics. From this perspective, the universe may have always existed in one form or another, changing, cycling, evolving, but never truly beginning. So we're left with profound questions. If the Big Bang wasn't the beginning, then what came before it? Could there be an endless sequence of universes? Could quantum events, each slightly different, shape the evolution of each new cosmos? Are we living in a universe influenced by the echoes of the one before it? In the world of physics, three main possibilities emerge. First, perhaps there is no physical explanation, the cycle simply is. Second, we might be part of an infinite chain of universes, each one birthed by the collapse of the previous. Third, the universe could be a repeating loop, where the end contains the seeds of its own beginning. Each of these ideas challenges everything we thought we understood about reality, and each of them brings us closer to understanding the ultimate question: why is there something rather than nothing? As we continue to explore these mysteries, new instruments like the James Webb Telescope and new models like Penrose's cyclic cosmology push the boundaries of what's possible. The idea that our universe is just one moment in an eternal sequence is no longer just science fiction. It's a real, testable scientific possibility. So what do you think? Is the Big Bang the true beginning, or just one beat in the infinite rhythm of the cosmos? Let us know in the comments, and if you enjoyed this journey through space, time, and reality, remember to like this video, subscribe to our channel, and share it with others who are fascinated by the mysteries of the universe. The journey has only just begun.